Digital sequential circuits. We have discussed various combinational circuits in earlier chapters. All these circuits have a set of output S, which depends only on the combination of present input. The following figure shows the block diagram of sequential circuits. This is combinational circuits. Input goes to combinational circuit and outputs or combinational circuit data goes to memory elements and then regoes combinational circuit. The sequential circuit contains a set of inputs and output S. The output S of sequential circuits depends not only on the combination of present input but also on the previous output S. Previous output is nothing but the present state. Therefore, sequential circuits contain combinational circuits along with memory storage element. Some sequential circuits may not contain combination circuit, but only memory elements. Following table shows the differences between combinational circuits and sequential circuits. Combinational circuits, sequential circuits, outputs depend only on present inputs. Output depends on both present inputs and present state. Feedback path is not present. Feedback path is present. Memory elements are not required. Memory elements are required. Clock signal is not required. Clock signal is required. Easy to design, difficult to design. Types of sequential circuits. Following are the two types of sequential circuits. One asynchronous sequential circuit and two synchronous sequential circuit. Asynchronous sequential circuits. If some or all the outputs of a sequential circuit do not change effect with respect to active transition of clock signal, then the sequential circuit is called as asynchronous sequential circuit. That means all the outputs of asynchronous sequential circuits do not change effect at the same time. Therefore, most of the outputs of asynchronous sequential circuits are not in synchronous with either only positive edge or only negative edge of clock signal. Synchronous sequential circuit. If all the outputs of sequential circuit change effect with respect to active transition of clock signal, then that sequential circuit is called the synchronous sequential circuit. That means all the outputs of synchronous sequential circuit change effect at the same time. Therefore, the outputs of synchronous sequential circuit are in synchronous with either only positive edges or only negative edges of clock signal. Clock signal and triggering. In this section, let us discuss about the clock signal and types of triggering one by one. Clock signal. Clock signal is a periodic signal and its on time and off time need not be the same. We can represent the clock signal as a square wave. When both its on time and off time are same, The clock signal is shown in the following figure. 0 voltage, 5 voltage. This is on off, on off. This is time period. In the above figure, square wave is considered as a clock signal. This signal stays at logic high 5 voltage for some time and stay at logic low 0 voltage for equal amount of time. Time period equal. This pattern repeats with some time period. In this case, the time period will be equal or either twice of on time or twice of off time. We can represent the clock signal as train of pulses. When on time and off time are not same, this clock signal is shown in the following figure. 0 voltage, 5 voltage. Time period long, short, off, on off, on off. In the above figure, train of pulses is considered as clock signal. The signal stays at logic high 5 voltage for some time and stay at logic low 0 voltage for some other time. The patterns repeat with some time period. In this case, the time period will be equal to sum of on time and off time. The reciprocal of the time period of clock signal is known as the frequency of the clock signal. All sequential circuits are operated with clock signal. So the frequency at which the sequential circuit can be operated accordingly, the clock signal frequency has to be chosen. Types of triggering. Following are the two possible types of triggering that are used in sequential circuits. One, level triggering, two, edge triggering. Level triggering. There are two levels, namely logic high and logic low in clock signal. Following are the two types of level triggering. One, positive level triggering and negative level triggering. If the sequential circuit is operated with the clock signal, when it is in logic high, then the type of triggering is known as positive level triggering. It is highlighted in below figure. Okay. If the sequential circuit is operated with the clock signal when it is in logic low, then the type of the triggering is known as negative level triggering. It is highlighted in the following figure. Edge triggering. There are two types of transition that occurs in clock signal. That means the clock signal transition either from logic low to logic high or logic high to logic low. Following are the two types of edge triggering based on transmission of clock signal. One, positive edge triggering and two, negative edge triggering. If the sequential circuit is operated with the clock signal that is transitioning from logic low to logic high, then that type of triggering is known as positive edge triggering. It is also called as rising edge triggering. It is shown in the following figure. If the sequential circuit is operated with a clock signal that is transitioning from logic high to logic low, then that type of triggering is known as negative edge triggering. It is also called as falling edge triggering. It is shown in the following figure. In coming chapters, we will discuss about various sequential circuits based on the type of triggering that can be used in it.